So I wanted to welcome everyone to kind of bracing yourself for the world of data-centric AI. We sometimes say kind of garbage in, garbage out. Data itself drives the model, not the model itself. And so what I have here is a team of kind of industry experts in both data and model building to talk about how data is driving AI. Do each of you want to kind of introduce yourselves, kind of go around? Feel free to kind of hop in and introduce yourselves, so a little bit about yourself and the company that you're with.
Sure, I can start. Hey, I'm Mike. I'm co-founder and CEO of Tecton. We are the feature store company, so we'll talk about that. And is there any other question to answer there? Was that it?
That's it, Mike. You got it.
That's it. Dan, do you want to go next?
Yeah, I'm Dan Jeffries. I'm the Chief Technical Evangelist at Pachyderm, which is a data versioning and lineage company, and also the Managing Director at the AI Infrastructure Alliance, which a number of folks are members of here.
And Diego.
Hey everyone, I'm Diego Oppenheimer. I'm an Executive Vice President at DataRobot. We're a machine learning platform company. Previous to DataRobot, they acquired my company. I was the CEO and founder of a company called Algorithmia, which was a MLOps, enterprise MLOps company.
Great. And Robert.
Hey, I'm Robert. I'm one of the co-founders and CEO of AnyScale, where we are commercializing Ray, which is an open source project, and we are aiming to build a compute layer for AI.
And I do think this group of people represents really an amazing set of people that touch some of the top model building, data processing, and feature delivery platforms out there. So you kind of amazing brain trust of folks here. Let me start with on the data side with Dan. Dan with Pachyderm, you kind of are in an interesting spot in the ML lifecycle. We're really touching almost the entire kind of data lifecycle. Any insights into what's leading data science and ML teams and how they approach data? How has it changed in the last couple of years? Love to just hear your view from where you come from.
Well, look, I mean, I think data is secondary in traditional coding, right? You write handwritten logic. If I'm writing a login script, I only touch the data when I grab the username and password to check it, and so it's secondary. Whereas data becomes the centerpiece in artificial intelligence and machine learning, right? And then if we look at this kind of data-centric AI movement that Andrew Ng, who's been, writing Pachyderm's marketing for him, I just want to thank Andrew personally for that, is, it's like the idea though that we've put so much time into developing these models, right? That it's largely a solved problem. And traditionally what you would have done is say, great, we're gonna import the data, clean it, do a bunch of things, but then basically treat it as fixed and then do all our iterations, in the algorithm. And the truth is now, like, are you really going to come up with something better than YOLO 5 by, your hyperparameter, open source hyperparameter tool? Like, good luck, but probably not, right? So the idea becomes like, instead of trying to solve a problem, like let's say you're doing, I don't know, you're trying to pick out voice commands in a car, and you find out that some of the samples, have noise in them, and it performs really poorly there. Traditionally, you try to fix it in the experiment tracking and all that, but in a data-centric approach, you might go, look, we're going to create a bunch of synthetic data. I don't need a data scientist. I need an audio engineer and a traditional programmer to go grab a bunch of background noise and kids screaming, are we there yet? And like music, and layer those into a sample and create new samples to try to solve it in that way. Or if there's kind of a screw up in the bounding boxes, I want to go define my rules better so that we fix the rules so that 20 people who are labeling it come to a consensus, and that works better. So that's kind of right in our wheelhouse in terms of being like language agnostic and being able to push and pull data and do all kinds of crazy things. And I think if Andrew's right, then that's the way it's going over the next decade. And it's kind of a big shift from where we are right now.
I mean, following up on that, do you feel like the industry, is there a theme across companies? Are people buying into this? It does feel like maybe 5 years ago it was building the better model, or just really very model focused. Do you see this kind of data-centric world coming across companies, or is there certain verticals where it's happening more often, or is this kind of everywhere right now?
I think it's coming into a lot of different places. I mean, Andrew started it basically when he was doing consulting for computer vision that led to landing AI, particularly in manufacturing. And you're going to have a point where you have sort of these foundational models, and let DeepMind and OpenAI and those folks kind of build these foundational models. And then you're going to tweak it based on the data set. But each one of those manufacturing groups is going to need their own data set. Like if, they're all building different widgets, and you're going to have to build your own sort of, steel plate with defects, or your own, solar panel with defects data set. And you're going to have to be able to deal with that and then kind of tweak it from there. So I think his big point, and I think this is true, is not everybody's Google and Netflix and wherever else. You don't have these gigantic, 5 trillion, input data sets, right? That you can then go grab. Like, you're going to have something smaller, which means you're going to have to employ critical thinking. And so I think for a lot of companies, especially in the enterprise space, it's going to be the default way that they deal with all of this stuff. And you're going to grab a foundational model and just tweak it.
Yeah, and I think it's a good segue. So there's probably no one who touches more companies in enterprise than DataRobot. Diego, how do you see? I saw the acquisition of Pixata and thought it was like an amazing move by DataRobot. How do you guys? How does DataRobot see data, and how does that fit into kind of what you're building there?
Yeah, absolutely. And so the technology now is called data mesh, and it's really about how do you feed data into model, into the workflow for training, right? And so it's interesting because in a lot of cases, what DataRobot does is it actually allows the subject matter expert on that data to be able to one who's actually like slicing and dicing the data sets, putting them together, and kind of like setting it up. And so the technology is really about, first of all, we're kind of seeing two things, right? There's like the example, one example, which is like, what Robert's working on, which is like these massive data sets and this massive infrastructure that is needed to train kind of like, these like, there's also a lot of techniques that are allowing to build effective machine learning models with way less data, right? And so you have kind of both things that are actually being approached. And in a lot of cases, it's really just about, okay, how do I quickly, in a reproducible way, and something that I can share with other folks in my organization as a subject matter expert of the data, right? Be able to quickly put together a data set that somebody can actually now use for an auto ML task, an auto time series stack, or even for training a model. So it's really about, kind of like a lot of times there's expertise in the data sets. And like, this is from a previous life, but in the world of BI, there's this concept of like data stewardship. Right. So you have these like data stewards that were actually like the people who understood those databases, the views, the semantic models, and they could actually be really helpful. And I think there's a lot of that is starting to pop up, where as ML becomes more accessible to more parts of the organized, like you want to be able to bring in those, subject matter experts of that data.
And I think as you talk about like, data steward, I mean, Mike, from a future store perspective, are you empowering these stewards of data? Are you the steward of the data when you're thinking about future store? And how does the future store play into this kind of data ecosystem?
Well, I mean, I think some of the trends that were just mentioned, like people, if you go back 5 years building ML, there's a lot of focus on the models, and everybody knows that. And then the whole data-centric AI kind of wave started. And I think it's interesting because it not only enables someone to bring their own data for into more complicated models, some more advanced model that someone at Google has trained for them, but a lot of use cases just have, like, the model is not really the big deal. And so a lot of the use cases, they're just training a pretty simple model. You just need a simple model. You just need to have the right data for it. And a lot of the challenge is kind of like, what data am I connecting to this ML application? So we spend a lot of time, in the feature store, feature platform world, thinking about how can we make it as easy as possible for an ML application to use the right data that is within the business. Because if you're trying to make impact on a machine learning application, bringing in the right data is more valuable than like extracting the right features from that data, and that's more valuable than tuning the model in a specific way. So, an example from Uber, when we were building the Michelangelo system, we were building the ETA models, and there was all this all this work to fine tune these models, and hey, what if we transform the data in this way or another way, and what information can we extract, essentially, how much more accurate can we make the models? And at the end of the day, we realized, like, why don't we just get the real-time traffic signals and feed them right into the model? There's a data source that we had never really used in those models, and that brought like an order of magnitude increase in accuracy. And I suspect, since it's early days for ML, for most organizations, there's all that low-hanging fruit available in terms of like connecting to the right data sources, and not just like making that connection, but operationalizing that and making it possible to use an ML application. And that's really what we're focused on, is how do you kind of like interface from that kind of like raw data to the model and make that as easy as possible.
And do you, I guess this is one kind of asking both you and Diego, do you guys see the world differently? Does the more citizen data scientists, kind of fast work on the data, view the world of data differently than maybe scale delivery of consistent features across an organization? Are there different uses in teams and how they use it, or are these problems just common, and it's the same problems across the same groups?
I think there's a lot of the same problems, but there's a lot of unique challenges in putting stuff into production as well. So some of the problems that are in common is like governance, and like making sure we're not duplicating our work, and making sure things are reusable and stuff like that. But when you get into real-time serving, and this has to be serving at scale, there's just like fundamentally different engineering challenges that have to be solved along the way. And historically, in the kind of previous generation of ML, companies would hire, huge engineering teams, and they would build custom data stacks to support all of this stuff. And that's really hard to do, because then you have, it's a lot of work, and then that's what was slowing down ML and making ML really painful. And so the kind of new challenge is, how do we enable a team to use a lot of their existing data tooling to easily build a production ML application and solve those same production challenges that are, those production challenges that are unique to production. That's not what all of the analysts and the offline people deal with, but solve that with the same set of tooling, the same product interfaces, the same set of kind of like core ML components, as it were. And I think that's like what this next breed of tooling is enabling. But I'm curious what Diego would say here.
I hope we're not supposed to disagree, because I don't.
No, you are supposed to disagree.
On principle. I mean, I think that's it, right? Like, you just have, so there's at the core of it, like the use cases drive kind of like the operational kind of like conditions of this, right? Like, is it a low latency use case? Does it have does it have an SLA that it needs to be? Like, how mission critical is that, right? Like, you have, like we're working on a use case the other day, it's like pretty much 1/3 of all the effects trading of the world goes through it, right? That's pretty important, right? That's like crashing economy style, like scale, right? And so pretty important, right? SLAs are important operations. So, and that's very different from exactly what Mike said, which is, hey, I'm literally just going to look at, can I do clustering on a bunch of my users to understand them a little bit better in a use case?
Like a one-off prediction kind of thing.
Yeah, exactly, right? I just want to get, or maybe not a one-off, it's like a batch process that I run like every, quarter to understand, like, are my users changing, right? And so like the operations, like, change. The part that's consistent, right, which is really interesting, is as the use cases multiply, right? And as if you have more, especially as you have more and more people participating in kind of like the development of machine learning models and kind of applying ML to use cases, the rigor around security and scale and governance and understanding what's going on, and auditability and observability across the entire stack becomes even more important, because you have sprawl. And sprawl is not a bad thing. It's only a bad thing if you don't know what's happening.
And I think Robert kind of want to kind of hit on pieces here around kind of differences in views, and all, one point was scale. As I think of any scale, love to hear how you view the view the data side, kind of if there's any differences, I guess, with how Tekton sees it. Really, I see your side. I see all the stuff you're building around making it easy to kind of get scale in very similar environments you're used to building models, maybe right from your Python, right from your local Python, and scaling that up. Love to hear a little bit about what you see from your side, and how it relates to what Tecton's view and folks.
Yeah, certainly. I think it's a great question. And scale comes into play in many different ways, right? From the data side to the compute side to the number of models you're deploying to the number of people collaborating on these projects. And we see scale as something that's becoming increasingly essential. And of course, you can still prototype and do machine learning. You can still demonstrate value on your laptop. But to really, if you look at where things are going, if you look at the amount of compute required to train language models, or to do get the really to really get a competitive edge here, I think the choice of whether to scale or not to scale is not so much an option anymore. And the challenge here is around how do you succeed with machine learning without a huge, just a tremendous infrastructure investment, right? How do you enable organizations to be able to, how do you really create a productive environment for developers so that you have super high developer velocity? And I think a big part of that, and what the approach we want to take here is to enable, to make the experience of building scalable applications not that different from the experience of building, applications on your laptop, right? So if you can kind of get to the point where to do machine learning, to if you know how to write programs and say write Python applications on your laptop, that's kind of enough. Then from there you can get all the benefits of the cloud to scale and kind of build your application in a future-proof way. So as you have more data, or as your models are getting bigger, or as you have more models, you don't have to go and get a PhD in distributed systems. The code you're writing and the applications you're building will just continue to work in that setting. So that's sort of the direction that we're excited about, and really trying to make that just work for people. And
I'm this might be a little bit of a controversial question across the team here, but do you guys feel that scale is a bigger problem industry-wise? Do you guys feel that iterating quicker on small data sets, in fact, is a bigger problem industry-wise? What do you think is the bigger market? Here's love to hear from you guys on that.
Yeah, I'm sure there'll be a lot of different opinions here. I think if you're deploying one model and sort of leaving it at that, and of course that's not what most people are doing, but if you're just deploying one model, it's not so bad. I think a lot of the challenges do come from needing to scale that model, or needing to deploy many models, and needing to integrate that model. We have a machine learning model, but needing to integrate that with other business and application logic. So that is where we see companies starting to invest in infrastructure teams and really start to run into challenges there. But I'd be curious to hear what others are thinking.
I mean, you asked a tough question of which ones are going to make money. That's an open question, right? So, I mean, partly it's, we're working on the first report in the AI Infrastructure Alliance, right, about the state of the industry. And most of the reports that have been out there, like Algorithmia did an awesome one on just sort of the state of ML adoption. And there's been a number of reports around that. And then there's been a number of reports about kind of the state of AI research, like how far along is it? But there really hasn't been anything on the state of the infrastructure and where these things stand. So my brain is sort of fully ensconced and kind of looking at these different things, and I'm semi-surprised by it, right, in terms of the things that I'm looking at. But if I started, we started to break it down by the different categories that are out there, right? There's feature stores, there's data versioning lineage, there's ETL, there's serving, deployability, observability. There's all these kinds of bits that are in there, and so we're looking at each individual piece. One of the ones that surprised me, it doesn't surprise me that you need kind of a scaled architecture, like something that Anyscale's doing, or Data Robots AI Cloud is doing. That's no different than running a high scale web application, right? You need a lot of instances. It's probably Kubernetes, it's probably containers or a microservice, and you have to serve it. There's some unique bits to it, maybe if you're doing RL. So that doesn't surprise me. I think you're always going to need that, right? What did sort of surprise me is looking at something like Scale AI or, or Snorkel, some of the folks that are coming around, and some of those that are pulling in like a huge chunk of, kind of annual recurring revenue. Initially, I looked at that and thought, well, just labeling, like why, like, don't you just put bounty box around stuff? Like, why is that making money? But it started to occur to me that it really speaks closer to the data-centric AI approach, meaning you have all these giant organizations. Like I think Scale just did the $250 million contract or whatever with the, with the government, because you have these data sets where they don't know what to do with them and they don't know how to, they're trying to get them labeled to put them in. And that's a huge problem within there. And it's not just brute forcing it with Mechanical Turk, right? Because you could do that. It's also like, can you automate part of that procedure too, right? So can you take bits of this thing and kind of automate, that procedure? But then I also start to look at things like, generating synthetic data, right? I mean, you look at, some of the stuff Lyft is doing, the sort of Uber competitor, right? They're generating tons of kind of synthetic environments or virtual environments. And when they found that, the cars were slamming on the brakes because they couldn't recognize like a yellow left-hand turn signal because 98% of the roads are green, they didn't go take pictures of them. They had artists come in and paint it, right? And put it into the synthetic data environment so they could simulate it. So there's a lot of different problems that are out there. I think it's a given that serving and monitoring and things like that requires scale. I think that's almost kind of like, I'm sorry, any scale, but it's sort of like, it's almost like a duh. And so like, good for you, it's going to be good for you, no question about it. And for Data Robot and everyone else. But I think some of the surprising ones are like on the labeling side, that annotating, like getting all that data in there, twisting it around. I think that's where there's a ton of money sort of coming into the space, and it's really, it's challenging and something nobody's thought about before.
Why are labeling companies making so much money?
Let me answer your previous one, Jim. So I'll take a position. I'll say iteration speed beats everything. So this thing called, like, I don't know if you know Boyd's law of iteration. So Colonel Boyd was the guy who looked at, like fights between like MiGs and like F-86s. And he had like determined that, observing, orienting, planning, and acting better was worse than actually doing the same things and acting faster. And so I literally think here there's an iteration speed, and the faster, and this is kind of like my, preaching call on MLOps, which is the faster you can iterate through the entire system, you are going to be better every single time on that. And so it's really about iteration speed and being able to react quicker, because what we're looking at, right, at the core of machine learning, we're looking at optimizations, and we're looking at better decision making, and market opportunities close. And it's really about the arbitrage of those opportunities. So iterating through those opportunities as fast as possible is the winning recipe. So that's my position on that question.
I do think all of you kind of do fit in that, how do we help people move faster? How do we help development teams? So like, there definitely is a theme across almost, I think, every company in this mix here. I guess on that, bottoming out that labeling one, any other comments on like the, I guess is the reason synthetic data companies are also making, starting to show up, or synthetic data starting to show up as well, industry wise, is that related to the dollars in labeling or getting good data to train your models? You guys, any takes on that?
I mean, I think it's, it's related to that. I think it's the big factor I would point out is I think synthetic data tech is becoming a lot better. So that's a factor there.
Got it.
It's easier to algorithmically generate something. It's cheaper to algorithmically generate something than to hire people. I used to run the human labeling team at Google. Very expensive to have people, going through Mechanical Turk things all day. That's expensive stuff. So you can, it is, and it's not even correct. There's accuracy, that's a whole other challenge. And then you're building a whole like system to manage the accuracy of to reduce human mistakes, and that's a whole like engineering direction you can go that can get kind of scary. I think one thing also that's interesting is, when we talk about data-centric AI, it's easy to talk about it's kind of like very top of mind often to think about like the labeling to big model training loop, and then go collect more data kind of thing. And I think what that's not the domain that Tecton plays in, so we don't like work with those use cases too much. But we see the same. We deal with data-centric AI. We see it when someone's building a fraud model, when someone's building a personalization model. And they ultimately, every one of these ML applications still has that loop. We call it the ML flywheel in our company, but it's, you know, they have some application that's making some decisions, just like Diego just said, and then they're collecting some information from what happened in the application. They're organizing it in some way. They're learning from, so then that's your data that's in your warehouse or something, and you're organizing it to turn it into training data. You're learning from it, and then you're deciding, and then that's the loop. And the same way, like, hey, it's really important for your ML ops team to be able to iterate quickly. The ML teams that are really good at the teams that build really high quality ML applications, they manage that loop really well. And so it's not just the learn phase, it's not just the deciding phase, but they're also thinking about, hey, how does my data get from my application back into a solid training data set? And they're playing in all parts of that cycle, and they're making that a much faster cycle as well. So I think of that as like another part of the data-centric AI like whole initiative and the whole wave that that we see every single day.
I mean, that labeling aspect of it that you talked about is part of that practical data-centric approach, right? I mean, Andrew talks about that specifically, saying like, great, you know, we ran it through five different algorithms and had a 0.2% improvement rate. And then we went back and looked at, okay, there's 30% of them that are labeled differently because we did it through 30 people and they interpreted the instructions differently. So the answer is not go back and think, why don't these idiots get it and understand what, you know, I'm a genius and I created the perfect rule set. It's to go, wait a minute, what didn't I convey clearly enough? And then it goes back to the thing sort of Diego was talking about, it, like how fast can you iterate on that loop, right? So then there's kind of the concept that like you have to have a domain expert in there. You talked about the steward. So if I'm trying to label the solar panels, for instance, and I say go label all the defects in it, you know, there might be small defects that one group of people don't label. Now, you as a domain expert might go, wait a minute, these aren't that important. In other words, I can still ship this panel and it's not going to actually, you know, cause degradation, or it might be perceived by the user as a degradation. So I do have to have these labeled. So I need to go have these 20% go back and be versioned and iterated through. And then there's also the aspect even of like helping augment that process. Like you talked about the sort of mechanical turkey. One of the reasons where you want to find out who makes money, who can speed up the slowest part of the pipeline. And the slowest part of that pipeline in some respects is having the humans go through it step by step and label it in. So if you can do instant segmentation, if you can go, look, we've got computer vision and go automatically draw bounding boxes around anything that looks relatively interesting, that if that speeds you up by 20% so that people can go and click things faster, then all of a sudden, yeah, now surprise, you've made money rather than hiring 300 people and paying
3,000.
Right, or 3,000 or 10,000 people to go do this and try to brute force it. Eventually you run out of steam.
Yeah.
One thing I do want to like call out here, you know, and again, like, I mean, obviously labeling, you know, I think it's, you know, the fact that there's so much focus on the labeling is also because of, you know, where it is in maturity cycle, but also, you know, it's mostly associated with unstructured data, right? Which obviously is exciting and it's growing way faster than structured data. But like, if I take like a temperature, you know, today, and I go look at production ML, right? There is way more structured data use cases in production being used today than there is unstructured. Now, we all get to work on the bleeding edge. So we're probably like half of our head is in that unstructured world. But, you know, when I go look at, you know, most of the use cases, you know, that, you know, you see today, there's a lot of structured data use cases. And those, you know, it's not labeling, right? It's ETL at that point, right? Like you're just like transforming, moving around, creating semantic models, like, you know, stuff like that. You're not doing labeling stuff. And that's the majority. Again, all these six use cases are in unstructured data. Don't get me wrong. I think so too. But, you know, when we actually truly look at, you know, what's moving the needle for the businesses today, the's just more structured data.
And the structured data use cases, though, there is a labeling step, but that step is you just record, you log, did the guy click the ad or something like that's your label.
Yeah.
And so there's always that step. And so that loop is kind of available, or it is necessary in every ML application. And you know, in the past, the whole focus was, wow, can we build the learn stage? Can we build the decide? Can we build this loop? And now we're getting to the point where it's easier and easier to have the loop in the right place. And we're talking about how can we make it easy for someone who's got business expertise, who's a subject matter expert, to maintain this loop and get this and manage this loop to get it to do what they want, the right business outcomes on the other side. I think that's the kind of fundamental shift. It's no longer like ideally, it's no longer a technical problem of like, hey, can I connect this thing to this thing and get a prediction out? But like a more of a business, and can I get the right business impact from this type of ML application loop that I've built?
And I guess this is another semi-controversial question. And maybe I'll start with Robert on it. But do you think the systems, the technology, the MLOps systems that we're building should be both structured and unstructured, so should support structured and unstructured together? I see people building like bespoke, almost, image-centric, MLOps solutions, or self-driving, focus on self-driving. Is that just an entry point? And does everything need to handle, reinforcement learning and unstructured data, or are we gonna have like a system for everything?
Yeah, I think, I don't think you want to go down the bespoke solution path. And this comes back to the iteration speed and developer velocity that we were talking about. But if moving from one domain to another, or one application to another workload means learning a new tool, learning a new system, or stitching different systems together, it's just going to slow you down. And I think, and this is something, again, we are very much thinking about the compute side of the story here with Ray and Anyscale. But we are trying to build, Ray is intended to be a very general purpose compute layer, so that you can use it to scale the data loading and pre-processing, to the training, to the model deployment and serving, to reinforcement learning. And and our hope is that will give rise to really a rich ecosystem that you can use to essentially support arbitrary scalable applications on top. And so one of the some of the benefits there for developers are, you just have to learn, like you just write Python applications and you just have to learn how to use this one kind of programming framework. And in contrast, if you're using, say, Spark for your data processing, if you're using distributed TensorFlow for your training, you've got another system for serving, got another system for hyperparameter tuning, then as a developer, your job gets much harder, because you're learning all these different tools. They're not necessarily designed to to integrate with each other. And of course, I'm talking about the compute layer. So we are not, at Anyscale, we're not like a one-stop shop for all of machine learning. We're for feature stores and things like that, we need to integrate with Tekton. We need to integrate with tools like weights and biases, or MLflow, or Arize, for observability. So but when it comes to compute, at least that we've seen, the generality makes a big difference in terms of developer productivity and the kinds of applications we can support.
And anyone else want to take the unstructured is everything going to have to support everything?
No, first of all,
what's that?
So there's a number of marketing teams that shall remain nameless, Lakehouse, that say that there's kind of a gigantic unified structured and unstructured data platform. And the truth is, it only exists in the mind of marketers. There's always a trade-off, right? You have a number of different things, right? Databases are generally going to be more performant for structured data, and you could throw them into an object store and you can retrieve them that way, but they're not going to be as fast in terms of retrieval. Versus trying to shove, a 1 gigabyte video, into a paragraph file is probably not going to be as performant in terms of, it's going to get chopped up, you're going to have to get it. So the sort of semi-structured and structured data sort of fits really well in that kind of paragraph file, the types of things you see on a Snowflake and Databricks and things like that. And object stores tend to be the places where you're storing a lot of the unstructured data, the audio, video, things like that. The holy grail is to get to a unified system that can kind of deal with both of them in a super performant way. I think the truth is that, certainly Pachyderm would love to get to that point, but are we there yet? I don't think so. I think we can handle both types of data, but again, it's going to be a trade-off in terms of the types of things you work on. We primarily do unstructured data. We're making moves into the structured side of the house, but I think the truth is that a lot of data also has gravity, if we're being honest about it, right? And you're not just deploying your system into a place that has a blank slate. Rarely, right? It's like you're going to come into an enterprise and there's going to be a bunch of stuff sitting in Oracle and Snowflake and S3 and 20 other object stores in your NFS mount or whatever. And you're either going to have to ingest, or you're going to have to go to where the data is. And so something that kind of does beautiful sort of ingress and egress and aggregates across a lot of those things right, is the kind of tool that you're going to need to be able to deal with, right? And Pachyderm a lot of times will act as almost a runner to those types of things when we see it. Like they'll go do a query. Someone will write, because it's language agnostic, they'll go grab a bunch of stuff from Snowflake, pull it in, do transformations and put it back in there, things like that. Nobody thus far has created the unified standard for these things. I don't know what it looks like, and we've been trying to solve that problem probably for 30 or 40 or 50 years in computer science, and I'm not sure that there's an easy answer to it.
And I guess on the business angle of this, any of you have any insights on like where the money is? So for is scale AI funded by just VCs pouring money into self-driving cars? Like what is the money? Like what are the business problems today that you see? Is it is it dealing with structured data? Is it unstructured data? Where are the dollars today driving these systems?
I don't think it has to be an or, right? I mean, I think there's a lot of, it's at the end of the day, like, what is the use case?
Yeah.
Like, what is it being solved for? Is it like, is it, self-driving cars? Well, yeah, they need massive amounts of data. They need massive amounts of like training, like they're, and why? Because, well, that's the future of, automobiles. So like, is there money there? Absolutely. So you have, you're trying to get as quickly as possible to solve for that. If you're looking in finance and you're doing, bond pricing, then like your opportunity is, okay, can I make a better bond price? What do I need there? Okay, I need the data feeds that are coming from the public markets. I need to have like some signal. I'm building. So I think I wouldn't classify as the money's in one place or the other, or actually say, I think there's very specific use cases that either optimize a business or make a better decision. And then you're just trying to race as quickly as possible. And any component that gets you to the result, a measurable result, faster, is valuable, right? And so you can pour money into each one of those. And if one part of the trail doesn't exist, then there's going to be a lot of energy and money spent on figuring out around that component that doesn't exist, right? So I can't say it's an or, right? Like, I mean, it's like I just don't see them as one being above the other.
Yeah, and at the end of the day, the ML is solving a business problem in some way, and that's some value to the business, and it could be on either side of that.
I think though the insight there is, it's in the use cases that are solving a business problem. And if you're working on use cases that are not, then the money is not there.
Yeah.
I mean, long term, what doesn't benefit from more intelligence? Like when you really look at this on a long enough timeline, 20, 30, 40, 50 years into it, like, is there any industry on earth that's not going to be touched by AML? Right? Are you not going to want to go look at your crops and see which ones are rotting so that you can spray pesticide better? Are you not going to want to build a better fraud detection model? Are you not going to want to, an AI driven, machine learning driven, bond trading mechanism, right? You're already going beyond all the hedge funds and stuff that I talked are already beyond, right? The kind of standard rules based systems and going to, to ML, right? Are you not going to, if you're in material science, are you not going to do it? If you're in drug discovery. So I don't think that the question is whether the industries are going to have use cases. The use cases, AI may be the most ubiquitous technology to ever be born in the history of man, right? When you start to look at it, there's nothing that is going to benefit from being dumber. Everything benefits from being more intelligent, right? And being able to make better decisions. The question in the short term, though, is, can the tools meet the gap of where the industry is now in order to solve the problems that are being solved now? And that decides the winners and losers, I think, more than whether are they in the right place at the right time, and are they solving a problem that exists right now, right? In the long term, feature stores and huge scale, deployment engines and transformation engines and observability all have a place in the ecosystem. It's just a question of, is everyone on this call, one of the winners, or do we get gobbled up by one of the winners, or are we all working together because we went to work for the winner in the long term? That's really the hard thing to figure out in the short term.
And as you think about this modular approach, where there's kind of deep technology solutions, which the teams here are building, I guess no data-centric AI panel would be complete without asking, at least on Mike's side, can you describe a little bit of what a feature story is? I know last year you'd say it, and people you'd be probably, no one would know, and I still see the question come up in like the ML ops community and constantly like, what is a feature store? What's it good? You know, what's it used for? How does it deal with data? And then maybe also add in a little bit of like how you see, does it move into unstructured? Do you serve embeddings? You have a whole embeddings panel, you know, talking about that. Like, how do you see it kind of evolve over time too?
Yep. I think, you know, what we're doing with the feature store is just trying to make very natural APIs for people who are developing machine learning to be able to handle the underlying data challenges that they face when they're dealing with the challenges of having a different development environment and a production environment, and dealing with these different concepts, these different ML concepts. There's nothing that's giving you an API for you to manage features. So without a feature store, you're thinking in tables, and you're thinking in data pipelines, and you know, updates to your tables, and running Airflow and things like that. And what we've done with the feature store and the concept behind it is there's a lot of data engineering that you have to do to build a production ML application. Let's automate as much as possible, simplify that as much as possible to make it very simple for you to describe what you really want as a data scientist. Hey, I really want this SQL snippet to be my feature, and I want to be able to do my real-time ML with it, or my offline ML with it. And that may hide behind the scenes orchestration of some feature compute that runs on any scale. It may hide some monitoring that happens with Arize. It may hide some real-time serving at scale for your fraud model in production that has to operate super reliably. And so the goal is to make it really simple for someone to kind of develop and operationalize and maintain this area of data pipelines for ML, which is just like the hardest, the kind of like grittiest, nastiest place in the ML lifecycle right now. And make it super simple for people to get that done. And your second question was
feature stores in like the future of feature store too. Like, as you think of, is it embedded? Is it unstructured data?
Yeah, you asked about unstructured data versus structured data.
Yeah, and is it
we
embedded?
Yeah, certainly embeddings. We already handle embeddings. The majority of, so in the future, certainly, I think everybody will say, hey, like unstructured data and structured data, you would want to support both of those longer term. But I agree with the points of like, hey, fundamentally, like when you're building a high performance system, you're going to be able to make optimizations that will kind of focus in on a certain use case that will be tuned towards specific requirements. And a lot of the use cases where feature stores are being used today is in structured data. And so that's kind of like where we've been focusing in on recently, and what's kind of in, at least in the intermediate term future. But longer term, like I mentioned, that loop, that ML flywheel, that's, all parts of that are parts where a data scientist wants to get something done, but they have to work with another engineering team. They don't really know how to describe to the other engineer what to do, and the other engineer doesn't really understand what the data scientist wants, and it's kind of annoying. But there's pretty simple ways to translate what the data scientist is looking for into the underlying data engineering work. And so we're taking on that whole loop to try to kind of model out what that ML problem is and operationalize it and integrate with the other tools, the other underlying components to send work to them, to send a job to any scale, for example, to do some of the processing that's needed at the different stages there.
Got it. And I guess Diego and team, do you see feature stores as, is this something that, are there different customer bases even between you folks? And is there some where the data robots kind of almost like a citizen data scientist empowering solution, and maybe that isn't what's used? Like how do you see data used across different organizations, and are different organizations, do different organizations pick up different components of what you guys offer depending upon what their use case is?
Yeah, I mean, so let's be clear, like Data does not offer a feature store. We've talked to Mike for a while about that. And so, there's an
Yeah.
integration component and,
Yeah.
and I think the use cases, as Mike put it, right? Like there's use cases that absolutely require a feature store and that you want it. And there are other cases where you don't need it and it's very use case driven. And there's a lot of high value use cases, very high value use cases that absolutely, it's like a crucial component. You're not going to get to it,
Yeah.
without it. From a data robot perspective, we have, kind of like 4 pillars of, what the platform does. You have kind of like what I call like that data acquisition, munging, kind of like preparation step, really just building the models and pipelines to feed it into the training. We obviously have what we call kind of ML dev, which is how do you train a component? So everything from auto ML, auto time series, but also like if you want to manually, on the, you want to manually train models to the MLOps component, deploy, monitor, govern, and then the delivery mechanism all the way to doing kind of like these like what if applications and integration. So you can modularize it. I've always been previous to Data Robot, and I will continue like pounding on it. And I've joined the AI Infrastructure Alliance with Daniel. Like I think modular infrastructures and architectures is the way to go. I've always said it, tightly integrated, loosely coupled. That's the way to the future. That's how you actually design large scale systems. I have 40 years of software like history to prove that that's the way that you should do it, in terms of building it. So, I'm sticking to that.
It's and I think this whole group probably is bought into that for sure. Thinking like maybe we will kind of end us on a little bit of the cutting edge. So as you think about, I don't touch it as much, but reinforcement learning, is there anything around the data and how you think of data there that's different? And maybe it's Robert. I'm guessing you touched this probably more than most folks here, but maybe Dan, I don't know if you touched it as well, but love to hear a little bit about that cutting edge use case and any data. How do you think about data differently?
Yeah, and reinforcement learning is actually one of the earliest use cases we had in mind when building Ray. And of course, for people who don't know about reinforcement learning, it's instead of taking your input and making a prediction or producing one output or one label, you're often making a sequence or a series of decisions in some environment that's changing dynamically. And the data story with reinforcement learning, it's all over the place. There are certainly a lot of high profile gaming applications where you're training an agent to play a game, right? And that where all of the data is essentially simulated, right? And of course there's a ton of data, but it's all simulated, so that you don't really end up with the labeling problem as much. On the other end of the spectrum, you have a lot of people building recommendation systems with reinforcement learning, and there you very much are collecting data from the real world, from the behavior choices people are making on the platform, and how people are responding to the recommendations that you give them. I think an interesting, one exciting direction with reinforcement learning, which is making it easier to apply, is the idea of offline reinforcement learning. So essentially, instead of doing trial and error in production, which is requires a different sort of instrumentation, it can be more challenging to set up. You have your deployed models, you're collecting data, you're logging data, and then you're using reinforcement learning to learn from those logs kind of offline. And then once you have that, you can deploy the model. And so once you've trained it, so there the kind of model development and production lifecycle looks more similar to deep learning or other more traditional machine learning applications. And that's we've been seeing a lot more heading in that direction. And
so anyone else want to kind of before finishing off, kind of as you think about the future, I do think reinforcement learning is kind of cutting edge, at least what we see. As you think about the future of this next year, the year after, call it immediate future. Any other areas you think are big in your mind in terms of data? And I'll throw out one we're thinking a lot about is just embeddings. We have an embeddings panel, and a lot of stuff we're thinking about and seeing in industry is around understanding that those data structures. And but love to hear from this panel what you see, and at least given what you touch. is kind of the next generation of things to worry about.
There's the long-term generation, right? Where you're talking about kind of, I just, did a bunch of research to try to figure out where we are on artificial intelligence, essentially can learn multiple things with the same model. And I thought, it would be really pie in the sky. And I found out that a number of researchers are already doing this kind of stuff, right? They've got sort of progress and compressed models, and they're able to have these kind of, dual neural networks, one that kind of learns things, and then it drops all the weights back into the gigantic neural net model and does elastic weight consolidation and figures out, how to freeze parts of the neurons. So we're starting to get to some really advanced things. I think RL is super on the cutting edge. I think the average company is probably not going to be using RL, right? It's like if you're, there's a reason a lot of the RL is confined to like sort of games or simulated environments or whatever it's, because it's super challenging to like feed data in real time to an agent that's making a decision, right? And so like it's why a lot of like like you said, that it's sort of simulated or whatever. I think reinforcement learning matters a great deal. In the short term, though, like what I tend to look at is sort of the total infrastructure evolving, right? And we're still in that kind of like early adoption phase. Like despite all the trillion dollars that's flowed into it, and despite there being like a lot of like really impactful use cases, the fact is it's still kind of trickling out of, the Netflixes and the Googles and the Ubers and things of the world down to the enterprises. And so I'm looking at like this kind of Cambridge's explosion of infrastructure. And I always like to joke that at the AI Infrastructure Alliance, we're working together now because we're all going to be working together later anyway, right? In other words, like there's going to be consolidation, and there's going to be groups that kind of cross over, and there's going to be you're going to be working together with partners because not everybody can do this. And so we're going to start to see some parts of the stack solidify.
Yeah.
And then we're going to start to see some of those come together, right? You'll probably see these big loops of companies that are like, okay, great, I'm on the deployment, serving, observability side, and that's like a huge structure. Or I'm on the ingestion, cleaning, training, labeling, feature store, construction kind of thing here, right? And I'm on whatever it is. Like you start to see those kind of like consolidations of things, and you also start to see more standard tools over the next 5 or 10 years. When you look at kind of early web development, there were 50 different web servers in the early 90s. Like how many web servers can you name now, right? You can name Apache and Nginx, and they've got 60% of the market. And if you're lucky, you might be able to pull Lightspeed out of a hat, at 7%, right? So I think at some point in time, we do start to say, this is a baked piece of the stack, right? And there's not going to be any more money in that. That's just the way that it's done. And the money allows it. We move up the stack to solve more interesting problems.
And so we are at time here. I want to thank all of you for coming to this session. Amazing talk. It's slightly controversial, but not too controversial. So thank you all though for your time. Amazing group here, and please catch the other sessions where we go more in depth on some topics.
Thanks for having us.
Thanks so much.
Appreciate it.